Have you ever wondered how to make your satellite images actually look like a real photo, or even highlight features you can't see with the naked eye? Let's bring your Landsat scene to life in Python. Welcome back to Remote Sensing Pro. If you followed the last tutorial, you've learned how to open a Landsat band in Python and see it in black and white, or with a color map like this. Today we will level up. We are going to combine several bands to build color images that show the landscape as the sensor sees it, and also help you spot things you can't see with the naked eye. Now let's use Python to grab those file paths automatically, so you don't have to dig through folders by hand. I will start by importing the library glob and creating a folder. I'll quickly grab the folder we used in our last tutorial, where we extracted the files, right? And next I'm going to create the file paths for the bands that I need. I'll do that with glob.glob, and then get the folder that I created. And then add Okay, so I've just created the path for band 2 within the folder for any file that has the extension b2.tiff. And now I'm going to do the same for the rest of the bands that I need. Just copy and paste. Okay. So here I'm going to change it to band 3, band 4, and band 5. Then change the bands to be a different extension to match with the bands. Okay. So we have band 2 to 5. Awesome. I'll go ahead to print. I'll print as blue band, as band 2, and I'm going to print the green as band 3, do the red as band 4, and finally near infrared band as band 5. Okay, let's go through this real quick. So we have the bands band 2 to 5, and the directories that can fetch the bands within the folder. Alright, and now I want to print the blue band as band 2, green as band 3, red as band 4, and infrared as band 5. Okay, let's run this. Awesome. So this quick search helps to grab the files that we need from the folder. Here we have a blue band, the green, the red, and the near infrared. Now let's read each band into Python using Rasterio, just like we did for a single band before. Think of each band as a layer in our future color photo. I'm going to start by importing Rasterio with Rasterio.open. we'd want to open band 2 as, I just do B, make it simple for ourselves. And then we do the blue band is equal to B dot read the first band. Okay, let's do the same for the rest of the bands to make it quicker as well. Alright, so we just do the same and we do band 3, band 3, band 4, band 5. And we're gonna change as usual, green, red, and near infrared. Alright, we've imported the Rasterio, and now we want to open the bands using Rasterio.open. We've got band 2 as our blue band here to read the first band, the green as band 3, the red as band 4, and the near as band 5. Awesome. Now we've got 4 arrays in Python, one for each band. We're almost ready to stack them together. Let's do that. This is where the magic happens. A true color image stacks the red, the green, and the blue into a single picture, just like the channels in your phone camera. Whereas a false color composite lets us see things like healthy vegetation by combining the near infrared with red and green. Let's stack them with numpy. So I'm going to import numpy this time. Let's do import numpy as np. We do true color is equal to np.dstack. I'm going to create the red, green, and the blue that we want to stack here. Okay, I need to double this bracket. I will do same for the false color is equal to numpy.dstack. What do we want to stack this time? We're going to stack the near infrared, the red, and the green. And also double. Done. Now each of these is a full color image, just waiting to be displayed. Alright, let's see what happens if we display the color composites right after stacking with no processing. I will start by importing matplotlib.pyplot as plt. Good. Then I'm going to do plt.figure so I can control the fig size. Let me do 4x4. Next is plt.imshow. And so I will do the true color first of all. So we see how it looks like directly without processing. Awesome. plt.show. Okay. Oh, I missed this. You notice how the image looks all white, right? That's because the raw satellite pixel values are much higher than what we expect, or rather what Python expects. So everything just gets maxed out and turns white. So we're going to fix this by stretching the bands in the next step, so the colors and details show up properly. Let's now stretch the bands for better visualization. Stretching bands just means scaling the data so the lowest value becomes black and the highest becomes white. That's full color. And this helps us spot features and patterns much more easily. To do that, we're going to define a function for the stretch. So we do define stretch, and we want to return our stretched result. And we're going to use the min and max for this stretching. Do band minus band dot min divided by band, the max, minus band dot min. Okay. Awesome. We've just defined the function to stretch the bands for us, and now we're going to apply that to the true color and the false color that we want to show. So I'm going to create, let me say, true display. Yeah. And for the true display, I'm looking at stretching or applying the stretch we just defined above on these images right here. Let's see the stacked ones. Alright, so we've got the numpy stack we did earlier. We just need to apply this stretch to each of the bands. To do that, we'll do stretch to red, and then apply the stretch again to green, and stretch the blue one. Okay, and I will do same for the false display. Okay, I will just grab this and change the bands to near infrared, red, and green. That makes it easier, right? Let's have a look at this real quick. We have the true display, numpy stack, stretch red, stretch green, and stretch blue. Great. For the false display, we have the same but different bands. We have the near infrared, red, and green. Good. Now let's plot. Plt dot, let's just say imshow. Plt dot imshow. What do you want to plot this time? The true color, true display, and plt dot show. I will do same for the false color as well. Plt dot imshow false display and plt dot show. Alright, everything is okay. Let's have a look at this. Good, so we have the first true color right here, and we have the false color. You see, after stretching, you will notice details in vegetation, water, and some areas within the images that are almost invisible before. So I also have an optional stretch, the 2% linear stretch. Sometimes a few super dark or super bright pixels can mess up our picture. So stretching differently that ignores those extremes or makes the image pop is also a great option. And a 2% linear stretch is one of those options. And how to get this done is almost the same as what we did right up here. So define the linear stretch, guess the range of the percentage you want to stretch. Here we're doing 2%, and that's what we're doing 2 and 98 here. And then you compute the percentiles right here. And finally, it's just to clip and stretch the bands by using the same method we used earlier in the min and max. Finally, return the stretched images. And to be able to view that, you need to first apply that function to the images. So like we did earlier, we had our stacked images and we applied the stretch, right? And below, all we just need to do is to apply the linear stretch here to red, green, and blue color. And this is for the true color image. After which we do what? We plot that, right? So if you plot this now, it's going to show the 2% linear stretch for the true color image. Let's have a look at that. You see? And if you apply the stretch to the false color also, all you need to do here is apply it to near infrared, red, and green. And that will change this to false color stretch. So we'll do false. This is for the false color stretch, near infrared, red, and green. And we have, let's plot the false color. See? So here is the false color, and this is our true color as compared to these ones. So there are different stretching options out there. So the difference between the min max stretch we did earlier and this 2% linear stretch is that for the first one, it scales between the absolute mean and max values, just as you can see here, right? We have the mean and we have the max. And this is kind of sensitive to outliers like clouds or shadows, which can skew the display sometimes. However, for this 2% linear stretch, it ignores the darkest 2% and brightest 2% pixels to improve contrast and avoid influence from extreme values. So how much more the feature stands out with 2%, right? And it's a simple but powerful enhancement. And that's a wrap for today. You've learned how to make true and false color images from Landsat data and stretch them to reveal real details. Please like and subscribe if this helped, and drop your questions below. And see you next time.